Dashboards offer location-based analytics using intuitive and interactive data visualizations at a glance. This past couple of months, we've been working around the story of great data being a cornerstone of every great dashboard. But as we know, we don't always get great data. Maybe your business requirements have evolved and your data is not caught up with it. Or maybe you have no control over how the data is structured or what metrics are measured. Or maybe the data that you need are captured in 2 or more data sets. To address some of these pain points, we will be introducing a new feature called data expressions. Dashboard data expressions is simply an arcade expression that returns a feature set. Using this expression language, authors can reconstruct data sets to power any dashboard element. And in turn, those elements can help form an engaging and informative dashboard. Here's a dashboard that informs and updates the viewers on the COVID-19 vaccination status across the US, and it further breaks the data down to state-level vaccination status and vaccination allocation by different manufacturers. Now let's leverage data expressions to take this dashboard to the next level. At the bottom, we have 3 serial charts using 3 different data layers. It is showing how many vaccines were allocated each week by each manufacturer. While you can roughly see the temporal trends through these charts, it's kind of hard to summarize this data at a glance. Using data expressions, we can actually pull data insights from multiple data sources to power a single element, effectively combining these 3 charts into one powerful visualization. With the latest release, we will introduce the option for users to switch out the data layer for a data expression. Here is an expression where we first access all 3 data layers, 1 per manufacturer, as a feature set, aggregate the features by the week of allocation to calculate the total number of vaccines allocated that week. Once we do this for all 3 data layers, we can loop through the feature set and store the feature attributes in an empty dictionary and return that dictionary cast as a feature set to power the element. With data powered by data expressions, we can effectively summarize how many doses were allocated per week by each manufacturer. Now we can configure a chart by pulling the categories from the week of allocation field, splitting the data by manufacturer, and setting the value as the total number of vaccines allocated per week. And this time, instead of showing this information in 3 separate serial charts, we can stack the series as such to show both the cumulative count of vaccines allocated per week and how many vaccines were allocated by each manufacturer. And with a little more configuration, we can enhance the chart so the colors match our pie chart. So let's hop over to the next dashboard to see what the enhanced chart looks like. Using data expressions, we were able to save precious dashboard real estate and combine multiple elements using multiple data sources into a single visualization. On the right, we have a list that shows the percentages of vaccinated population in each state. A common pain point when using temporal data that contains records for each day is that the data structure becomes a known limitation in the list configuration process. For instance, to prevent repeating features in the list, we have to use a date filter to filter for the latest records. When you're using data that is updating on a daily basis, it can be a hassle to have to reconfigure your list every single day. So how convenient would it be if we could simply automate this updating process? And that's where data expressions come in. Using data expressions, we can actually find the most current date from a date column and use that date as a filter. Additionally, we can retrieve rows that correspond to records from exactly a week ago to calculate weekly vaccination changes. We can loop through the filtered feature set and store the feature attributes in an empty dictionary and return that dictionary cast as a feature set to power the element. Now let's configure our list, and this time we're going to use Arcade for advanced formatting to enhance our list layout. Here's an Arcade script that controls the formatting properties of the list, using logic that, for instance, determines whether an arrow icon points up or down depending on the weekly vaccination change. We can also use a custom HTML script to enhance the list items. Using advanced formatting, we're able to provide visual indicators such as progress bars and arrows, and classifiers using different colors to communicate how each state is doing with regards to vaccination. Now let's hop over to the final dashboard to see what everything looks like polished up. Using data expressions, we were able to automate the data updating process and uncover hidden information in our data. We were able to transform a dashboard that felt somewhat crowded and not so intuitive into one that is easy to comprehend and informative. Data expressions effectively give us more control over how to transform data to enhance data visualization, and it is a key tool for driving a more compelling narrative through dashboards.